Welcome to Data Leadership for Everyone. I'm your host, Anthony Algman. Everyone needs to harness the power of data. There's a lot involved in making that happen, and this show is here to make it all a little bit easier. Think of this as an audio advice column for all your data and leadership questions. Our guest today is Jorge Sancha. In today's business climate, there's one thing organizations often need above all else: speed. That's where Jorge Sancha comes in. As the co-founder and CEO of Tinybird, he's building a world-class platform for developers and data teams, helping them turn data at any scale into meaningful insights, actions, and business value. With $40 million in funding at his back and a globally diverse team that's over 60 birdies strong, Jorge's out to prove that when armed with real-time data insights, there's nothing your organization can't do. Jorge, welcome to Data Leadership for Everyone.
Hey, thank you very much for having me, Anthony.
So I love your bio. That is quite an eloquent articulation of what it is that you do. But can you, in layman's terms, talk a little bit about what is Tinybird going out to solve? What is the problem that Tinybird is trying to help solve in the marketplace?
Sure. So Tinybird started out of a frustration, which was, hey, whenever there is huge amounts of data and I want to do something with it, while still fresh, while it's still almost in real time, let's say, as soon as the data is being generated, especially if I want to join it or enrich it with other sources of data, people throw cathedrals of infrastructure at that problem. You have data capturing software like Kafka. You have then some type of data lake where you store the data. Then you have tooling to move that data around. And then finally, if you want to build something, you still have to build a backend application, put it in some low latency storage, and then finally build an application, secure it, and deploy it. And it's a lot to do something that it's at its base pretty simple. I have data, yeah. I want to query it, I want to do some joins, and I want to expose it either internally within my organization for other people to do something with it, or as part of a product it's user facing, and that just like I do with any other data. So Tinybird aims to resolve that. It wants to help you unify your data from different data sources and quickly build APIs in a managed way. There's no infrastructure to set up or anything, such that anyone that knows how to write SQL is able to build APIs that can then power data products internally or externally. Does that make sense?
It does. It does. And I mean, I think the timing of this is absolutely essential because you have people who have been trying to use data in whatever capacity, but we know, like, in most jobs today, data's involved. I think you could argue every job today, data's involved in some way. But I think there's a greater awareness about the kind of, I don't know if I have an eloquent term, but like the building block nature of when I do something with my data and my work, I'm going to be handing that off to somebody else who's going to take that and do something with that and go from there. And so that kind of productization, that thought of how can I package this in a way that it's useful for somebody else, I think becomes really powerful. And we're just working with so much data, so many capabilities now that we need help. It's like, it wasn't long ago where, and it's still really happening, where spreadsheet, Excel hell type of thing, where you've just got stuff flying all over the place and no consistency, no reliability in any of it. We have to elevate beyond that. Is that something that Tinybird is helping us do?
Yeah, and we do this from sort of different points of view. One is, for smaller companies where you don't yet have a data stack, you have maybe your Postgres or MySQL application, or maybe you use some NoSQL such as Mongo or something like that, and you're building your application, and at some point you start realizing, oh, I need to run analytics on top of this data. I don't want to overload my main database to do these things. So we make it very simple for those types of teams with a great developer experience, to start sending data to Tinybird that you can analyze at any scale very easily just using SQL. That's one part of it. But we're also helping very large companies at a different stage, which is, the reality is, if you look at the data journey in many of these companies, they start adding some type of, their architecture in general starts becoming more complicated. They have microservices, data being moved around. A lot of people are using streaming data to send messages between applications and services. And then you add some type of source of analytical truth like Snowflake or BigQuery or something like that to start putting everything in one place so you can make sense of it. But even after you've done all of that, it's still a data that it's stored in one place that someone has the keys for, that there's a lot of handoffs between teams in order to build over that data. And generally data warehouses are not well suited for building applications on top of. They're great for BI and data science and sort of general purpose ad hoc queries, but they're not great as a database that needs to power a user facing application at scale and so on. So we help unlock and unfreeze all of that data and enable those data engineering teams to expose that data and to make it available to other teams within the organization. Again, just connecting to those data warehouses and setting up workspaces in Tinybird that they can exploit simply with SQL. So
Mhm.
those are the two levels at which we work. Is if both from a smaller company that wants to go really fast and doesn't want to set up any infrastructure, to bigger companies that are hitting diminishing returns in terms of both what their data warehouse can give them in terms of building applications, but also both in terms of how do we make all of this data available to the rest of the organization so that things can be built and we can ship faster and move faster. So, yeah.
It's an interesting thought. It's super relevant to some of the challenges I'm dealing with myself today. But it's
I have a
you
contract
you
right
think
here,
about
Anthony, for you to sign for a Tinybird account.
No, well, we'll talk about that later. But what I'm thinking about just from a pattern perspective is that I've spent my career in data analytics, data platforms, big scale stuff, right? I built data warehouses, massive things. And while you can accomplish a lot with that, a lot of scale with that, there's no doubt that that takes a lot of coordination at that kind of scale. But if you flip that on its head and you say, okay, well, an individual can move really quickly. They can do a lot of really nimble things, but a lot of the tools they have historically had don't scale because, and,
Yeah.
and they don't know as individuals how to get to that point where you're building these really massive systems at the same rate. And what's why it's relevant to me today is I'm literally going back and I, in a separate capacity, am trying to build a relatively simple application, and I can't get out of my own head because I'm so used to the really big stuff. I don't know how to do something simple anymore. And I can see that directional need, and what you just talked about I think is really important for us to understand. It can be a challenge not just to be the person who understands the simple and is trying to make it scale and go complex. It's also very challenging for a very large scale, very complex system to become simple and nimble as well.
Yeah, that's exactly right. I used to be a sort of a VP of engineering in a company, and there was a lot of discussion about making people sort of developers happy and give them like a good career path and so on. But my feeling was that developers in general, and engineers in general, what they care about is shipping and shipping
Mhm.
faster and being impactful. And if you set up the environment for them to ship faster, then they're happy. You don't have to worry so much about the rest of the stuff. And because that's what I used to be a developer as well. I don't code as much anymore, unfortunately. But that's where we come from. And from the data point of view, what we were seeing in large organizations was a similar situation where you have, because data is growing at an unprecedented speed, delivery becomes much slower and doing
Mhm.
anything becomes much harder, and you have to provision servers and you have to do ETL pipelines that move data from one place to another, and then whatever thing that is using that data downstream, if you want to make a change, you have to go upstream and find where exactly do I have to make that change, where's that new pre-aggregation that I need to bring in. And there's so much competition in the market today that we see a lot of companies that are waking up to, hey, we need to move much faster, we need to work with fresher data, and we need to enable engineering teams to build directly over the data so that there's no 1,000 steps and 1,000 handoffs between teams. And that's where Tinybird comes in. You can ingest data at huge scale and immediately query it as soon as it has been ingested. You can bring data from, for instance, Kafka, and also connect it to your Snowflake, and also bring in files, and then do queries that access all of those data sources once they've been ingested in Tinybird. So you can then publish with a click, or using our CLI and all our sort of development tooling to deploy in seconds, really at scale, because you don't have to provision the infrastructure either. So it's a very ambitious platform, but it's making some of our customers invest much more in data and engineers, and not so much in infrastructure teams, such that they can ship faster and more over all of the data that they have.
That sounds good. I guess then the question I would have is, how does this differ from what I would call more traditional or legacy cloud providers and some of the solutions that you're going to just see baked in AWS or Azure or something like that?
Yeah, if you think of cloud providers, they all have different components that you can put together to do different things. The problem with those components is, first, every time data flows through any of those components, you're being billed. That's number one.
Right.
Also, every component that it's going through, it's adding a layer of latency on top of that data. So if you're capturing data in one place, moving it to other place, and then another place, so all of those handoffs are making you be or less capable to work over fresh data. That's another thing, which, not all use cases need real-time data, but the reality is, once you start working with real-time data and you realize that it's possible and you can do it at cheaply as well, it's like, why would you do anything else? Why would you work with stale data when you can easily do the same with real-time data? And then finally, what you see, components like Redshift or Snowflake or BigQuery, those are great data warehouses, and they all have their good sides and bad sides. But at the end of the day, if you need to run 100 queries per second, or if you need to develop quickly over that, you're going to struggle because of all the things we've talked about. Either because you need to have access to those keys, either because you need to, it's not built to support certain use cases. So we don't pretend to replace data warehouses. We pretend to be a super fast publishing layer on top of your data and your streaming data or your batch data, such that more teams can build faster, and you can focus on shipping and not so much on moving data around.
There's a couple things that I like about this. First off, I spent about a decade in the proprietary trading and financial industry space, so I know like latency is a big deal in that space.
Yep.
Although I also know that most people don't need sub-second latency on most of what they're doing.
Yep.
That said, so park that one thought. Second thought is that I've long said, in absence of any other insight, solve for speed. Because what speed is an enabling function. When you are fast about something, you can do more because you can take more cycles.
Absolutely right.
Even if your cycles are less accurate, if you can execute more cycles, you can iterate faster to get to a conclusion. And that works at both like human speed and very fast computer speed. That is a really a key thing. The third thing that I often think about as well is you want to present the information or have the information available in a time frame that is slightly faster than the time frame in which you want to act. So if I'm making a decision once a day, I don't need that data every 5 minutes. I probably need that data once every day ish, right? And so if I can do something every hour, if I'm a person who's reacting to something every 5 minutes or 15 minutes or whatever, that gives you a gauge of how much streaming do you really need, how much low latency do you need. However, when you're trying to solve for the unknown, when you're trying to solve for the situation in which you can't reasonably predict all of the uses, but you know you need to solve for speed for the lowest latency requirement, you want to be a little bit better than that. So that's why solving for speed is always a good thing, because any new opportunity that handles this at a slower speed, then you're fine with. You're already providing that. And so if you can solve for the fastest speed up front, then your refactoring costs and your need to continue to engineer and enhance, you've kind of leapfrogged a bunch of those steps. And that's something that I think sounds, when it comes out of my mouth, I think that sounds relatively intuitive, but the way organizations actually work, they do not do that. They solve to a spec. They say, I need this every day. So they build an entire architecture to give it to them every day, as opposed to an architecture that could support real time streaming. And then when they're like, oh, you know what? We really do want real time streaming 6 months later. And then you're like, yeah, we're going to have to rebuild everything.
Yeah.
And that's the thing that blows my mind, is like, we don't realize how data actually works. It is not a hard and fast one-time thing. It is a moldable, malleable asset that the needs of it will evolve as our other capabilities are evolving as well.
That's look. There's so much to unpack on everything you've just said. But I love it because look, one of our core principles in our company in Tinybird is speed wins,
Mm-hmm.
and it applies to everything. It applies if you not even talking about data, but you take more, like if you think about decisions in a business, 80 or 90% of decisions are better served by making them fast than by you know optimizing for the optimal decision and taking longer to take them, because 80 to 90% of decisions are easily reversible. There's always
Mm-hmm.
decisions you need to think longer and ponder and so on, but in general, day to day, most decisions are better served by just taking them and move quickly and do more and iterate faster. But the same goes from a user experience point of view. If you're building a product and it loads instantly, that feeling and that well-being that you're generating the user, and that happiness and that user experience, it will compound. It'll be happier user doing more things and so on. If you go to the hardware and so on, if your queries take if you have 1,000 queries to do and they all take 1 second, you'll need 1,000 cores to serve those queries.
Mm-hmm.
But if you can make those queries run in 1 millisecond, you only need one core to serve those
Yeah.
queries in 1 second. Obviously 1 millisecond is, depending on what you're doing, it might be very little, but that's the order of magnitude that we're talking about. We're preparing. One of our biggest customers is the biggest fast fashion retailer in the world, and they're preparing for their sales period now and soon Black Friday and so on. And they've built personalized recommendations on the website built on Tinybird, and we have to deliver tens of thousands of requests per second. And in order to deliver that at cost, they need to be under 10 milliseconds. Those queries need to be super fast. So but you can do that at scale because the more queries you can fit in within the same infrastructure, the less infrastructure you have to do, more money that you can dedicate to something else. So
Mm-hmm.
that's pretty key. And the other area of speed that I think is important to understand is you were talking about how companies build to a spec, and a lot of people we talk to, they say, no, we don't need real time for this, or and actually the way we say is, hey, I totally understand that you've been working without real time for a long time and you're used to working like that. But the way you need to think about this is, what else could you do if this was real time? First,
Mm-hmm.
a lot of decisions that you now take on a daily basis, you could probably automate if it was real time.
Yeah.
Whereas now you have to look at the results over a day and make a decision. And if you reduce the time it takes to understand what's going on with your business, you can automate a lot of this stuff. It can completely change how your company operates. And we've seen that time and again with Tinybird, with users that they didn't realize that they could do some things in real time. And once they do, it's like, wow, this is so much better. What else can we do in real time? Because it really changes where to put the focus, how fast you can deliver. And from a development point of view, even if a developer is working and their queries take 20 milliseconds instead of 20 seconds,
Yep.
how much more can they do? They'll be happier developing. The feedback will be faster. They'll be in flow. Whereas if every query you run, it's an experiment that you have to wait for the results. That's not very productive. So it just applies everywhere, and we're crazy about speed.
It's interesting how speed and quality become almost synonymous, because I'm a big car guy, and I think about the software component of cars. Obviously, that wasn't really a big consideration 30 years ago, but it's now a bigger and bigger consideration. And it kind of still blows my mind that you have automakers out there who put very little attention or effort into the interfaces that exist in those kind of central hubs of their car. And if it's not snappy, if it's slow, it degrades the quality feeling of the entire product. And the
Yeah,
ironic thing to me
absolutely.
is that some of the luxury car makers are the worst offenders on this whole thing, is that they'll have these really buggy, slow, glitchy interfaces because a lot of times they're smaller makers that don't have as much resources to invest into software. But a random person who comes in, sits in the car, and it's like, oh yeah, nice interior, and even economy cars have nice interiors now. But you get to that interface, and when a Chevrolet's random interface that you're getting for your just video and audio components and navigation, everything, when that smokes what you're getting from a Maserati or a Bentley or something, you have a problem if you're Maserati or Bentley. And that's a solvable issue, but you're not going to do it alone. You're going to need help, because you're in the making a great car business. You're not in the making a great software business. And I think that's one of the things that we've seen, especially like in the advent of electric vehicles, is that traditional automakers are confused because they don't realize the importance of that software component now to anybody's car buying experience, or car ownership experience.
Yeah, yeah, makes sense.
So what I think about, broadly, so at an individual level, and we're starting to run out of time, but this has been a really interesting conversation. At an individual level, what what can Tinybird, or what can you teach people that may not be in a position to buy this for their entire organization, but want to benefit from some of the knowledge you've gained in the tools that you're working on?
Mhm. One thing to comment is Tinybird is also available self-service, so you can start for free. You have 1,000 requests you can make a day for free, so you can build small applications and so on with and very very easily, and test it out, and then you can scale from that as much as you want. I think some of the key learnings from some of the most impressive companies that we're working with is that. It's related to speed and about embracing speed, not just on the user experience, but also on development and how much faster can we go in terms of putting things out there. And I think embracing that in the day. I mean, just if you look at what's happening with AI, I mean, the world is moving faster and faster and faster. And you need to be comfortable with speed. You need to be comfortable with embracing everything that makes you faster. So that would be the number one piece of advice that I would give any developer and any data engineer, which is, hey, if your data pipelines are taking 20 minutes to run, you're probably doing something wrong, and there is probably technology out there that can help you make it faster. I mean, I'm sure there are things that are greatly designed, to and that take 20 minutes. I don't want to offend anyone here, but we've seen this time and again. Even people that are, spend millions in Databricks and then realize that 90% of what they are doing in Databricks they can do with Tinybird and other types of technologies as well. If you switch the mindset to real time and you start thinking, how could I build this in real time? And there's 4 or 5 things you need to learn about that, which is, you have to start thinking about not batch as in transformations that happen every once in a while, but transformations that are constantly happening as you ingest data. And then you need to think, you need to understand how to craft your queries so that, because even in Tinybird, which is a super fast system, you can make a slow query. Anybody can make a slow query in any database if they set their mind to it. But there are a few things that once you learn them about how to where do you put your filters, and filtering data that you don't need, not writing any data that you're not going to use, and all of those things. I think there's a 5 or 6 things that we tell all our customers, hey, just keep this in mind when you're developing, and you're going to cover 90% of what you're going to do. really fast and without any scalability problems.
That's really interesting. So we're just about out of time. Before we go though, what is the best way for people who want to learn more or reach out to you after the show? How can they get in touch or find out more information?
So the best way is to go to tinybird.co. You can, if you want to check out the product, you can sign up. We also have a Slack community that you can. It's free, and you can come in and ask questions and talk to data engineers. When you when you sign up, you get an email, and if you want to talk to a data engineer and one of the people that is working in Tinybird that solving problems with customers and providing feedback into the product and so on, that know not just our product but real-time databases inside out, and you can set up time with them. I'm in the pool, so you might get me as well, because I try to speak to as many people as possible, and so those are the best ways to talk to us. And you can. My email is very easy to guess. I'm not going to say it out loud here, but very easy to guess.
Fair enough. Jorge, thank you so much for being on the show today. This has been really interesting.
Absolutely. Thank you for having me.
Thank you. And this podcast is data leadership for everyone, but if you need some data leadership for you, I want to help. So send your questions to podcast@dl4e1.com, or my phone number is 773-888-2077 if you prefer to text or leave a voicemail. You can find subscription links and all our episodes at dataleadershipforeveryone.com. And until next time, be good to your data, be better to your business, and be best to each other. Now go make an impact.